June 15, 1943, 25,000 feet above the English Channel. German ace pilot Klaus Brenner squinted through his Messerschmitt's canopy at the approaching American formation. 8 P-47s, those fat, lumbering, flying milk bottles the Luftwaffe had been swatting from European skies for months. Brenner smirked. The Thunderbolts climbed like loaded freight trains, maxing out at barely 1,500 feet per minute, while his 109 could dance circles around them in a vertical fight. This would be another easy kill. But as Brenner pulled into his attack dive, something impossible happened. The lead P-47 didn't try to run or turn away. Instead, it pitched up into a climb so aggressive it defied everything Luftwaffe intelligence knew about American fighters. The massive aircraft clawed skyward at nearly 2,000 feet per minute, its engine screaming at full power, chasing Brenner into his own domain. In the cramped cockpit of his Messerschmitt, the German pilot felt his first taste of fear as the stupid American propeller, 13 feet of revolutionary paddle blade engineering, turned the sky's biggest joke into its most terrifying predator. The morning reports from the European theater painted a grim picture that no amount of Pentagon optimism could disguise. By September 1943, the P-47 Thunderbolt had earned a reputation that made seasoned American pilots request transfers to anything else with wings. The aircraft's nickname among Luftwaffe pilots, Jug for its milk bottle silhouette, had crossed enemy lines and now echoed through Allied briefing rooms with bitter irony. Colonel James Johnson flipped through the latest combat assessment reports at Wright Field, his coffee growing cold as the numbers told their unforgiving story. The P-47's climb rate of 1,500 feet per minute made it a sitting duck against Messerschmitt 109s that could ascend at over 3,000 feet per minute. In dogfights over occupied France, German pilots had developed a simple tactic: climb above the Thunderbolts and pick them off at leisure. The massive American fighter, weighing in at over 7 tons fully loaded, simply couldn't follow enemy aircraft into the vertical realm where modern air combat was decided. Frank Caldwell studied the same reports from his cramped office at Hamilton Standard Division, but where military commanders saw failure, the veteran engineer saw physics. The Pratt & Whitney R-2800 double WASP engine buried in the P-47's nose generated 2,300 horsepower, more raw power than any fighter engine in the world. Yet somehow all that energy was being wasted. The problem wasn't the engine or the airframe. The problem was the narrow-bladed propeller that couldn't absorb and translate that massive torque into forward thrust. Traditional propeller design had remained largely unchanged since the Great War. Engineers built them with thin knife-like blades that cut efficiently through the air at cruising speeds. But efficiency at cruise meant nothing when combat demanded maximum power. The P-47's standard propeller blades, just 11 feet in diameter, simply couldn't handle the full output of the R-2800 without losing effectiveness. At full throttle, the tips approached supersonic speeds, creating shock waves that destroyed lift and turned the propeller into an expensive air brake. The solution that formed in Caldwell's mind violated every principle of conventional propeller design. Instead of thin blades optimized for cruise efficiency, he envisioned broad paddle-shaped blades that could grab massive amounts of air and hurl it backward with brute force. The concept resembled a boat propeller more than an aircraft prop: thick, wide, almost clumsy-looking blades that prioritized raw thrust over elegant efficiency. His colleagues at Hamilton Standard listened to Caldwell's proposal with polite skepticism. Tom Richards, the division's senior aerodynamicist, pointed out the obvious problems: increased weight, higher drag at cruise speeds, and manufacturing complexity that would make mass production nearly impossible. The military had already invested millions in existing propeller tooling. Retooling entire production lines for an unproven design would cost a fortune and delay deliveries for months. But Caldwell had run the calculations. A 13-foot diameter propeller with paddle blades could absorb the full 2,300 horsepower output of the R-2800 engine. The increased thrust would overcome the additional drag, and the larger diameter would reduce tip speeds, eliminating the shockwave problem that plagued existing designs. More importantly, the new propeller would transform the P-47's abysmal climb rate into something that could compete with German fighters. The skepticism wasn't limited to Hamilton Standard's engineering staff. At Curtiss Electric, Hamilton's primary competitor in military propeller contracts, senior engineer Robert Hayes dismissed the paddle blade concept as a desperate attempt to fix an unfixable aircraft. Curtiss had their own solution in development, a refined version of their existing narrow blade design with improved pitch control and slightly larger diameter. Their approach was conservative, proven, and could be manufactured using existing tooling. The U.S. Army Air Forces found itself caught between competing philosophies. The conservative approach promised incremental improvements with minimal risk and cost. The radical approach promised revolutionary performance gains, but carried enormous technical and financial risks. Colonel Johnson, tasked with evaluating both proposals, faced a decision that would affect thousands of American pilots heading into combat over Europe. Meanwhile, across the Atlantic, Luftwaffe intelligence officers were tracking American aircraft development with characteristic German thoroughness. Major Wilhelm Specht, stationed at a Luftwaffe technical evaluation center in occupied France, had personally examined several captured P-47s. His reports to Berlin were dismissive. The American fighter was a brute force design that relied on heavy armor and powerful engines to compensate for poor aerodynamics. German pilots could exploit its sluggish climb rate and poor maneuverability indefinitely. Specht's confidence was shared throughout the Luftwaffe command structure. The Americans had proven they could build aircraft quickly and in massive quantities, but they seemed incapable of matching German engineering sophistication. The P-47 represented everything wrong with American aircraft design: big, heavy, crude, and inefficient. German pilots joked that shooting down a Thunderbolt was like hunting a flying refrigerator, difficult to miss and certain to fall once hit. The September test flights at Wright Field would determine which philosophy would equip American fighters for the crucial battles ahead. Caldwell's paddle blade propeller had been mounted on a single P-47D model for preliminary evaluation. The aircraft sat on the flight line looking almost comical. Its massive propeller blades resembled something designed for a cargo plane rather than a fighter. Test pilot Captain Robert Anderson climbed into the cockpit with orders to push the aircraft to its limits and report any performance changes. As Anderson taxied toward the runway, neither he nor the engineers watching from the control tower could imagine that they were about to witness the transformation of aerial warfare's biggest disappointment into its most feared predator. The conventional wisdom that had shaped fighter design for 2 decades was about to be shattered by 13 feet of revolutionary engineering that would rewrite the rules of air combat over Europe. The first test flight on October 12th lasted exactly 14 minutes before Captain Anderson brought the modified P-47 back to Wright Field with a disturbing vibration report. The massive paddle blades had created harmonic oscillations throughout the airframe that threatened to shake the aircraft apart at anything above 70% throttle. Frank Caldwell watched from the control tower as ground crews swarmed the aircraft, checking for stress fractures and loose rivets. The vibration problem wasn't entirely unexpected. Propeller harmonics had plagued aviation since the Wright brothers, but the intensity suggested fundamental flaws in the blade design. Caldwell's team spent the next 3 weeks redesigning the blade root attachment system and adjusting the propeller hub balance. The original blades had been manufactured using standard techniques that worked perfectly for narrow blade designs, but proved inadequate for the massive forces generated by the paddle configuration. Each blade weighed nearly twice as much as conventional designs, creating rotational stresses that the standard hub couldn't handle. The solution required custom-forged blade shanks and a completely redesigned hub assembly that added another 200 pounds to the aircraft's nose weight. The second test flight on November 5th produced different but equally frustrating results. The vibration problem had been resolved, but the new propeller's performance fell far short of Caldwell's calculations. Instead of the promised climb rate improvement to 1,900 feet per minute, Anderson reported barely 1,600 feet per minute, an improvement of only 100 feet per minute over the standard propeller. The top speed increase was similarly disappointing, with the aircraft reaching just 410 miles per hour compared to the baseline 400 miles per hour. Robert Hayes at Curtiss Electric received the disappointing test results with barely concealed satisfaction. His team's refined narrow blade design had completed its own initial testing the previous week with far more promising numbers. The Curtiss propeller achieved a climb rate of 1,750 feet per minute and maintained the aircraft's existing top speed without the weight penalty or manufacturing complexity of Caldwell's paddle blade design. Hayes forwarded his results to Colonel Johnson with a memo suggesting that Hamilton Standard's radical approach had proven itself a costly dead end. But Caldwell suspected the problem lay not with the paddle blade concept, but with the propeller's pitch settings and blade angle optimization. The initial design had been based on theoretical calculations that assumed perfect conditions. Real-world testing revealed that the optimal blade angle for climb performance differed significantly from the angle that produced maximum level flight speed. The P-47's constant speed propeller system could adjust pitch automatically during flight, but the range of adjustment had been calibrated for narrow blade designs. Working 18-hour days in Hamilton Standard's engineering lab, Caldwell's team developed a new constant speed mechanism with twice the pitch adjustment range of existing systems. The modification required extensive changes to the propeller governor and hydraulic controls, but it would allow the paddle blades to operate at optimal angles across the entire flight envelope. The redesigned system could shift from a coarse pitch setting for high-speed cruise to an extremely fine pitch for maximum static thrust during takeoff and climb. The engineering challenges went beyond mere pitch control. The paddle blades' increased surface area created cooling problems for the engine. The larger propeller disc pulled more air through the engine cowling, but the air moved more slowly due to the increased resistance. Engine temperatures climbed dangerously high during extended full-power operations, threatening to damage the R-28. 100 cylinders. Caldwell's team had to redesign the cowling's air intake system and add additional cooling louvers to maintain proper engine temperatures. Lieutenant Colonel Johnson faced mounting pressure from Pentagon officials who questioned whether the P-47 program deserved continued investment. The Boeing P-51 Mustang was showing exceptional promise in early testing, offering performance that surpassed both the standard P-47 and the proposed paddle blade modification. Some officials argued that resources would be better spent accelerating P-51 production rather than attempting to fix the Thunderbolt's fundamental limitations. The third test flight on December 8th finally demonstrated the paddle blade propeller's potential. With the new pitch control system and redesigned cooling, Anderson pushed the modified P-47 through a series of combat maneuvers that would have been impossible with the standard configuration. The aircraft climbed to 20,000 feet in 10 minutes and 40 seconds, a rate of 1,850 feet per minute that approached the performance of German fighters. More impressively, the Thunderbolt maintained this climb rate while carrying full combat weight, including armor, ammunition, and fuel. The speed trials produced equally encouraging results. At 25,000 feet, the modified P-47 achieved 445 miles per hour in level flight, a 45-mile-per-hour improvement over the baseline configuration. The increase came not from reduced drag, but from the propeller's improved ability to convert engine power into forward thrust. At high altitude where air density was reduced, the paddle blade's superior grip on the thin air provided a decisive advantage over conventional propeller designs. But the most significant discovery came during dive recovery tests. The P-47 had always been notorious for its reluctance to pull out of high-speed dives. The standard narrow-blade propeller provided insufficient thrust to overcome the aircraft's massive momentum and weight. Anderson found that the paddle blade propeller generated enough reverse thrust in the fine pitch setting to help the aircraft decelerate and recover from dives that would have been fatal with the original configuration. German intelligence reports from late December painted the modified P-47 as an interesting but ultimately irrelevant development. Luftwaffe analysts noted that the Americans were experimenting with larger propellers on their fighters, but dismissed the modifications as desperate attempts to improve an obsolete design. Major Specs assessment concluded that even with propeller improvements, the P-47 remained inferior to German fighters in every category except straight-line speed and diving ability. The December test results convinced Colonel Johnson to authorize limited production of the paddle blade propeller for operational testing. Hamilton Standard received a contract for 50 propeller units to be installed on P-47 D-22 aircraft scheduled for European deployment in early 1944. The order represented a significant gamble. If the paddle blade design failed in combat, American pilots would pay the price with their lives. Caldwell's team worked through the Christmas holidays preparing the production tooling and training manufacturing personnel on the new assembly procedures. Each paddle blade propeller required 40% more manufacturing time than conventional designs and cost nearly twice as much to produce. The financial risk was enormous, but the potential payoff, transforming the P-47 into a competitive fighter, justified the investment. As 1944 began, the first production paddle blade propellers left Hamilton Standard's factory bound for modification centers where they would be installed on Thunderbolts destined for the European theater. Neither the American engineers who built them nor the German pilots who would soon face them in combat could imagine how completely these 13 feet of revolutionary engineering would alter the balance of power in the skies over occupied Europe. The first paddle blade-equipped P-47s arrived at RAF Boxted on March 15, 1944, creating immediate controversy among the veteran pilots of the 356 Fighter Group. Captain Mike Gladich, a Polish exile with 12 confirmed kills, examined the massive propeller blades with undisguised skepticism. The blades looked crude and oversized compared to the elegant, narrow props he was accustomed to flying. Several pilots nicknamed the modified aircraft barn door specials and requested permission to continue flying their standard Thunderbolts until the new design proved itself in combat. Group Commander Colonel Harold Rao faced a delicate situation. His pilots had survived months of brutal air combat through skill and intimate knowledge of their aircraft's capabilities and limitations. Forcing them to fly unfamiliar equipment could prove fatal, but operational orders from 8th Air Force Headquarters were explicit. The modified P-47s were to be evaluated under actual combat conditions as quickly as possible. The success or failure of Caldwell's paddle blade design would be determined not in controlled test flights, but in life-or-death encounters with veteran Luftwaffe pilots over occupied Europe. The first combat mission for the modified Thunderbolts came on March 22nd during a bomber escort mission to Berlin. Gladich led a flight of 4 paddle blade P-47s as high cover for a formation of B-17 flying fortresses approaching the German capital. At 30,000 feet, well above the bombers, Gladich spotted a formation of Messerschmitt 109s diving from 35,000 feet in a classic bounce attack. Under normal circumstances, the P-47s would have been forced to dive away from the German fighters, using their superior speed in a descent to escape the Messerschmitt's climb advantage. Instead, Gladich pulled his flight into a steep climb to intercept the diving Messerschmitts. The paddle blade propellers clawed through the thin air at altitude with unprecedented authority, maintaining a climb rate of over 1,700 feet per minute, even at 30,000 feet, where standard propellers would have struggled to achieve half that performance. The German pilots, expecting the American fighters to dive away, found themselves facing P-47s climbing directly into their attack path with enough energy to engage in turning combat at high altitude. The engagement lasted less than 3 minutes, but shattered German assumptions about American fighter capabilities that had held true for over 2 years of combat. Gladich's wingman, Lieutenant Robert Johnson, managed to stay with a 109 through a series of climbing turns that would have been impossible with the standard propeller configuration. The Messerschmitt pilot, Major Hans Dormann, later reported to Luftwaffe intelligence that the American fighter had displayed climb performance equal to German aircraft, a claim that was initially dismissed as combat stress or pilot error. Word of the engagement spread quickly through Luftwaffe fighter units stationed in Western Europe. German pilots had developed tactics based on the certainty that they could outclimb any American fighter and dictate the terms of engagement from superior altitude. The possibility that P-47s could now compete in vertical maneuvering threatened to invalidate years of combat experience and tactical doctrine. Several group commanders requested immediate confirmation of American fighter modifications from intelligence sources. Major Wilhelm Specht's Technical Intelligence Unit captured its first paddle blade-equipped P-47 on April 2nd when Lieutenant Charles Morrison was forced to crash land near Calais after his aircraft was damaged by flak during a ground attack mission. Morrison successfully destroyed most of his aircraft's sensitive equipment before being captured, but the propeller remained intact for German examination. Specht's initial report described the paddle blades as grossly oversized and predicted that the modification would create more problems than it solved. The detailed technical analysis that followed revealed the sophistication of Caldwell's design. German engineers discovered that the paddle blades incorporated advanced metallurgy and precision manufacturing techniques that exceeded anything in current Luftwaffe production. The constant speed propeller mechanism showed innovations in hydraulic control systems that German designers had not yet developed. Most disturbing was the realization that the Americans had solved propeller efficiency problems that German engineers had considered unsolvable with existing technology. Combat reports from April and early May painted an increasingly grim picture for Luftwaffe operations in Western Europe. American P-47s were engaging German fighters in climbing combat and frequently emerging victorious. The 356th Fighter Group alone claimed 21 German aircraft destroyed during April, with most victories coming from engagements that standard P-47s could never have survived. German pilot losses were mounting as their altitude advantage, the cornerstone of Luftwaffe fighter tactics, began to evaporate. The tactical implications extended beyond individual dogfights. German fighter controllers had positioned their aircraft to attack American bomber formations from above, knowing that escorting P-47s couldn't climb quickly enough to interfere with the bounce attacks. The paddle blade propellers allowed American fighters to maintain station at bomber altitude and respond immediately to German attacks from any direction. Luftwaffe bomber interception missions that had previously succeeded through altitude advantage now faced immediate opposition from American escorts operating at full combat effectiveness. By mid-May, nearly every frontline P-47 in the European theater had been equipped with paddle blade propellers. The modification program had overcome initial manufacturing challenges and was producing propellers at a rate of 200 units per month. Hamilton Standard's factory in Connecticut operated around the clock to meet military demands, with Caldwell's engineering team working alongside production personnel to refine manufacturing processes and eliminate quality control problems. The statistical evidence of the paddle blade's impact became undeniable by month's end. P-47 units equipped with the new propellers reported a 40% increase in air-to-air victory rates compared to the same unit's performance with standard propellers. More significantly, P-47 loss rates had decreased by 30% as pilots gained the ability to climb away from dangerous situations instead of relying solely on diving speed for escape. The Thunderbolt was no longer the Luftwaffe's preferred target. Colonel Johnson received authorization in late May to expand the paddle blade modification program to all P-47 variants in production. The success in Europe had convinced Pentagon officials that Caldwell's stupid propeller trick represented one of the war's most significant technological breakthroughs. Orders went out to modify existing P-47s in the Pacific Theater and to equip all new production aircraft with paddle blade propellers from the factory. German intelligence officers struggled to explain the sudden improvement in American fighter performance to Luftwaffe commanders who had grown accustomed to tactical superiority over Allied fighters. Major Specht's updated reports acknowledged that the Americans had achieved a significant technological advantage, but German aircraft designers lacked the manufacturing capacity and raw materials to develop comparable propeller improvements. The Luftwaffe would have to face the remainder of the war knowing that their fighters could no longer dominate American opponents through superior climb performance and altitude advantage. The transformation was complete. Frank Caldwell's paddle blade propeller had turned the P-47 Thunderbolt from the Luftwaffe's favorite target into their most dangerous opponent, rewriting the tactical balance of air combat over Europe just months before the D-Day invasion would demand total Allied air superiority. D-Day morning brought the ultimate test of Frank Caldwell's engineering revolution as nearly 400 paddle blade-equipped P-47s roared across the English Channel at dawn on June 6, 1944. The massive air armada tasked with securing Allied air superiority over the Normandy beaches included more modified Thunderbolts than any previous operation, their distinctive broad propeller blades catching the first light of what would prove to be the longest day in aviation history. Colonel Francis Gabreski led the 56th Fighter Group sweep over Omaha Beach at 0630 hours, his 16 P-47s climbing to 25,000 feet, with an authority that would have been impossible just 6 months earlier. Below, the largest seaborne invasion in human history was unfolding as Allied landing craft approached the heavily fortified French coast. Above, German fighters were conspicuously absent from skies they had once dominated with impunity. The Luftwaffe's response to the invasion revealed the devastating impact of the paddle blade revolution on German tactical doctrine. Oberst Adolf Galland, commanding Luftflotte Reich's fighter forces, had been forced to abandon the altitude advantage tactics that had served German pilots since the Battle of Britain. His fighters could no longer count on outclimbing American escorts to attack Allied bombers from above. Instead, German pilots found themselves forced into low-altitude engagements where the P-47's superior firepower and armor provided decisive advantages. Major Klaus Miatusch's Jagdgeschwader received orders to intercept Allied fighter bombers attacking German positions near Caen, but the tactical situation had fundamentally changed since the paddle blade modifications began appearing over Europe. Miatusch's Focke-Wulf 190s, once capable of climbing above American fighters to dictate engagement terms, now found themselves matched or exceeded in vertical performance by Thunderbolts that could maintain combat effectiveness at any altitude. The morning's first major air battle developed over the invasion beaches, when 24 Messerschmitt 109s attempted to attack Allied naval forces supporting the landings. Captain Robert Johnson's flight of 8 paddle blade P-47s intercepted the German formation at 18,000 feet, climbing from sea level in just under 9 minutes, a rate that allowed them to reach the Messerschmitts before the German pilots could complete their attack runs on the vulnerable ships below. The engagement demonstrated how completely the paddle blade propeller had altered air combat dynamics. German pilots, who had learned to fight by climbing above their opponents, found themselves unable to escape American fighters that could match their climb rate and exceed their level flight speed. Lieutenant Hans Weick, flying his 43rd combat mission, reported that the American Thunderbolts climbed like rockets and maintained pursuit through maneuvers that would have shaken off P-47s equipped with standard propellers. By noon, Luftwaffe controllers were reporting American fighter activity at altitudes previously considered safe havens for German aircraft. P-47s were engaging German fighters at 30,000 feet and winning dogfights through superior energy management rather than the brute force tactics that had characterized earlier Thunderbolt operations. The paddle blade propellers allowed American pilots to trade altitude for speed and then regain altitude quickly enough to maintain tactical advantage throughout extended engagements. The statistical reality of D-Day air operations told the story of Caldwell's triumph in stark numbers. Allied air forces flew over 14,000 sorties on June 6th, while the Luftwaffe managed fewer than 300, a ratio that reflected not just numerical superiority, but the tactical dominance that paddle blade-equipped fighters had established over European skies. German pilots who did engage Allied formations found themselves outmaneuvered by American fighters that could climb, dive, and turn with effectiveness that rendered traditional Luftwaffe tactics obsolete. General der Jagdflieger Adolf Galland's evening briefing to Reichsmarschall Hermann Göring painted a devastating picture of German fighter impotence over the invasion beaches. Galland's pilots had claimed 17 Allied aircraft destroyed during the day's operations, but German losses exceeded 40 fighters, an exchange rate that would quickly eliminate the Luftwaffe as an effective fighting force. The paddle blade P-47s had proven themselves capable of defeating German fighters in every type of engagement, from low-altitude dogfights to high-altitude interceptions. The evening's final air battles occurred as German night fighters attempted to attack Allied naval forces under cover of darkness. The 8th Air Force had equipped several P-47 squadrons with experimental radar sets for night interception missions, and the paddle blade propellers proved essential for maintaining station with radar-equipped aircraft during complex night maneuvers. The Thunderbolts' improved climb performance allowed them to position themselves above German night fighters and attack with the same altitude advantage that Luftwaffe pilots had once enjoyed. Frank Caldwell received the first reports of D-Day air operations at Hamilton Standard's Connecticut factory, where his team was working around the clock to meet military demands for paddle blade propellers. The success over Normandy validated everything Caldwell had envisioned when he first proposed his revolutionary design. The stupid propeller trick had transformed American air power from a defensive force barely capable of protecting Allied bombers into an offensive weapon that could dominate European skies. The broader implications of the paddle blade's success extended far beyond individual air battles. Allied air superiority over the invasion beaches allowed ground forces to advance inland without the constant threat of German air attacks that had characterized earlier amphibious operations. The Luftwaffe's inability to contest Allied air operations effectively meant that German ground forces would face the remainder of the war without meaningful air support, a situation that would prove decisive in the campaign for Western Europe. German aircraft designers studying captured paddle blade propellers in late June reached sobering conclusions about American technological capabilities. The propeller modifications represented advances in metallurgy, precision manufacturing, and aerodynamic design that German industry could not match with existing resources. More disturbing was the realization that the Americans had solved the fundamental problem of converting high horsepower into effective thrust, a breakthrough that would provide lasting advantages in any future aircraft designs. As June ended and Allied forces consolidated their positions in Normandy, the strategic impact of Caldwell's engineering revolution became undeniable. The paddle blade propeller had not merely improved the P-47's performance, it had fundamentally altered the balance of air power over Europe. German pilots who had once hunted American fighters with confidence now found themselves the hunted, unable to escape Thunderbolts that could climb faster, fly higher, and fight more effectively than any German aircraft could match. The transformation was complete and irreversible. The aircraft once mocked as a flying milk bottle had become the terror of European skies, and the engineer who designed 13 feet of revolutionary propeller blades had changed the course of the air war over Europe. The Luftwaffe would never again enjoy the tactical advantages that had made German fighters the masters of European skies during the war's early years. The war's end found Frank Caldwell in his Hamilton Standard office on May 8, 1945, staring at production reports that told the story of his engineering revolution in cold numbers. Over 12,000 paddle blade propellers had rolled off American assembly lines since that first experimental installation in October 1943. Each one represented a small miracle of precision manufacturing that had required retooling entire factories and retraining thousands of workers to build something that conventional wisdom said couldn't work. Colonel Francis Gabreski's final mission report from the European theater provided the human dimension behind those production statistics. His 56th Fighter Group had flown over 15,000 combat sorties with paddle blade-equipped P-47s, claiming 438 enemy aircraft destroyed while losing only 47 Thunderbolts in air-to-air combat. The exchange ratio exceeded 9-1 in favor of American fighters, a performance that would have been impossible without the climb rate and altitude capability that Caldwell's propellers had provided. The statistical transformation of the P-47's combat record revealed the true magnitude of what 13 feet of revolutionary engineering had accomplished. Before the paddle blade modifications, Thunderbolt units typically achieved exchange ratios of 3-1 against German fighters, respectable but not decisive in a war of attrition. After the modifications, that ratio had tripled, turning every air engagement into a lopsided victory for American forces and hastening the collapse of German air resistance over Europe. Major Wilhelm Specht's final intelligence assessment, discovered in captured Luftwaffe files after Germany's surrender, acknowledged that the Americans had achieved a technological breakthrough of decisive importance with their propeller modifications. German engineers had attempted to develop similar improvements for their own fighters, but shortages of critical materials and manufacturing capacity had made meaningful progress impossible. The paddle blade propeller remained an exclusively American advantage throughout the war's final year. The human cost of that advantage was measured in American pilots who returned home alive instead of joining the casualty lists that had grown so long during the war's early years. Lieutenant Robert Johnson, who had scored his first victory with a paddle blade P-47 over Berlin in March 1944, flew his final combat mission with 28 confirmed kills and not a single loss to enemy fighters. His survival, multiplied across hundreds of American pilots, represented the most meaningful measure of Caldwell's engineering success. But the paddle blade's impact extended beyond individual pilot survival to reshape the entire strategic balance of the air war. German bomber production had ceased by early 1945, not because factories had been destroyed, but because the Luftwaffe could no longer provide fighter escorts capable of protecting bombers from American fighters. The paddle blade-equipped P-47s had made German air operations so costly that the Reich's aviation industry had simply abandoned bomber development in favor of desperate attempts to build defensive fighters. The technological revolution that began with Caldwell's unconventional thinking had spawned an entire generation of American aircraft innovations. The North American P-51 Mustang incorporated similar paddle blade technology in its final variants, as did the Republic P-47N model that began production just as the war ended. American aircraft designers had learned that brute force approaches to engineering problems could succeed when backed by superior manufacturing capability and materials science. Frank Caldwell's personal recognition came in the form of a Presidential Medal for Merit presented by Harry Truman in a quiet White House ceremony on June 15, 1945. The citation praised his revolutionary propeller design that materially contributed to Allied air superiority over Europe. But Caldwell knew that the real victory belonged to the thousands of American pilots who had flown his propellers into combat and returned safely home. The post-war analysis of German aircraft development revealed how completely the paddle blade revolution had disrupted enemy planning. Captured documents showed that German designers had abandoned several promising fighter projects in late 1944 because they could not match the climb performance that American fighters were demonstrating in combat. The psychological impact of facing P-47s that could outclimb German fighters had proven as devastating as the tactical advantages the propellers provided. The manufacturing legacy of the paddle blade program extended far beyond military aviation. American factories had developed precision casting and machining techniques for propeller production that found applications throughout post-war industry. The metallurgical advances required for the paddle blade's strength and weight specifications contributed to improvements in automotive engines, industrial machinery, and eventually commercial aviation. Caldwell's wartime innovation had accelerated American manufacturing capability by years. The strategic lessons of the paddle blade success were not lost on military planners preparing for potential future conflicts. The program had demonstrated that technological superiority could be achieved not just through revolutionary new designs, but through innovative applications of existing technology. American aircraft engines had always been powerful. The paddle blade propellers had simply found a way to use that power more effectively than anyone had thought possible. By summer's end, production lines that had manufactured paddle blade propellers were retooling for civilian aircraft applications. The same broad blade technology that had given P-47s their devastating climb rate was being adapted for transport aircraft and commercial airliners. Caldwell's wartime innovation was beginning its transformation into peacetime prosperity, promising to revolutionize civilian aviation just as completely as it had dominated military skies. The final measure of the paddle blade's success came from an unexpected source: captured German pilot interviews conducted after the war's end. Luftwaffe veterans consistently identified the appearance of modified American fighters as the turning point when German air superiority became untenable. Major Klaus Mitusch, who had survived over 200 combat missions, described the paddle blade P-47s as the aircraft that ended our war in the air. Frank Caldwell closed his final wartime engineering report with characteristic understatement, noting that the paddle blade propeller had exceeded design expectations in operational service. Behind that modest language lay the reality of an engineering revolution that had transformed American air power from defensive necessity to overwhelming dominance. The stupid propeller trick that colleagues had once dismissed as impractical had proven that sometimes the most unconventional ideas produce the most decisive results. The war was over, but Caldwell's revolution in propeller design would continue shaping aviation for decades to come. The principles he had established, that efficiency mattered less than effectiveness, that conventional wisdom deserved constant challenge, and that radical solutions often succeeded where incremental improvements failed, would guide American aerospace development through the jet age and beyond. 13 feet of paddle-shaped steel had changed far more than the performance of a single fighter aircraft. It had demonstrated the transformative power of engineering courage in the face of impossible challenges.